Hello all. So today we're going to be talking about our third free response topic, and that all these questions center around real world questions, and specifically they're giving us a rate of change in a function, and what we have to do with that is interpret that function, interpret that rate to answer a whole bunch of different questions. So what I've done to kind of start us off here is I have taken some different formulas and different things from your formula sheet that I've given you. And I just want to highlight these because a lot of these we're going to fall back on again and again. And you should know these things cold without any hesitation. But I just want to kind of review them with you, and then we'll get to going on practicing a couple problems. So first of all, different kinds of rates of change. There's two different kinds that you need to be aware of. Average rate of change, we call that AROC, and basically that's using this formula, and they would specifically ask for the average rate of change, and if they do that, that's the slope of the secant line, and you're using this formula. Okay, instantaneous rate of change is asking for a slope at a specific point, and that is the slope of the tangent line, and that's just the derivative at that given x value. Okay, what I want to point out is that average rate of change and average value are two very different things. If it's asking for the average value of a function, whatever that function is, if it's asking for the average rate, well then you would do the 1 over b minus a. So they will give you an interval. So if they said, what's the average rate of change for the first 10 minutes of the function? And so you would do 1 over 10 minus 0 times the integral from 0 to 10 of the function, okay? And the function would be the rate. So if you want the average rate, you would do the integral of the rate formula. And so that's important. Whatever you want the average of that function, you use that actual function in the integral. And then these, which we've talked about several different times, but just highlighting them again, if they're asking for a relative min or max, okay? You are going to, and actually if they ask for an absolute min or max, either way you're going to find your critical values by setting the first derivative equal to 0. Then where these differ is for a relative min or max, you're going to make a sign chart, and you are going to be answering questions like, when is f increasing? Well, that would be when f prime is greater than 0. Ooh, this should say decreasing. It's a mistake. F has a relative min when f prime changes from negative to positive, and a relative max when it changes from positive to negative. So you're using your sign chart to answer that question. And then the extreme value theorem, same thing, you find your critical values, but now you're going to use the closed interval test, and you're plugging it back into the original function. And then you are evaluating that for all those middle values, that would be their critical values, but as well also your endpoints A and B. And then you compare and determine the absolute min or absolute max. So just want to make that correction here, that this should say decreasing. Well, I guess I didn't. Okay, so make that correction for yourself on your formula sheet if you have that in front of you. Because I clearly made a mistake there. Okay, so those are some important distinctions. The other big one that you need to know is that if you want to find, if they give you a function that is a rate and they want a total, a grand total, you are doing the integral of the rate, because remember when we go backwards from a rate, we go to quantity. So that's a big one that is used a lot as well. All right, so let's move forward and try two of these free response questions. Okay, the first question that we're going to take a look at says, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by g of t equals 90 plus 45 cos of t squared over 18, where t is measured in hours from 0 to 8. At the beginning of the workday, t equals 0, the plant has 500 tons of unprocessed gravel. During the hours of operation, from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. Okay, so I want you to understand what's happening here, okay? This is the rate that it's arriving. So g of t is the rate at which the gravel is arriving. And then there's two different rates given, and I just want to point that out. So this is the one where it's arriving at the plant, and then this is the rate at which it's being processed. Okay, 100 tons per hour. So there's two different rates here that we have to recognize. Okay, the first question is just asking us to find g prime of 5, and we're using correct units. Interpret the answer in the context of your problem. So if they're asking us to evaluate g prime of 5, well, that's asking me to take the g function, which is given right here, take its derivative, and then plug in the 5. Well, we are using a calculator for this question, so we definitely want to use that math choice 8 to do the derivative at x equals 5 or t equals 5. So we're going to go ahead and just plug it into our calculator to get an answer here. So you should be picking up your calculator and do math 8 and enter this in, and then come back to me with an answer. Okay, so when I entered this in my calculator, I got that g prime of 5 was equal to negative 24.588. All right, now I have to interpret this and use the correct units. All right, so let's talk about what did g of x represent, g of t. G of t represented the rate at which the unprocessed gravel was arriving at the processing plant. All right, so that's the rate it was arriving. Now, if I take the derivative of a rate, what is that really doing? Well, it's the slope of that rate. So if I think about it, if my slope is negative, what is that telling me about the rate at which the unprocessed gravel is arriving? Well, I would say because it's negative, that would tell me that the rate is decreasing. Okay, so my rate is decreasing by how much? Well, by 24.588. And then what is my units here? Tons per hour, but because I took the derivative, it's per hour squared or tons per hour per hour. So usually we say tons per hour squared. Okay, so I'm going to write on my answer. I'm going to say the rate at which the gravel was arriving at t equals 5 hours was decreasing by 24.588 tons per hour squared. So the rate at which the gravel was arriving at t equals 5 hours, so I gave the time, was decreasing by 24.588 tons per hour squared. Okay, so I'm defining the derivative of a rate by talking about whether or not it's increasing or decreasing, whether or not the rate is increasing or decreasing at that time. All right, let's move on to part B. Okay, part B asks us to find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So this is what I was talking about on that opening introduction for rates. If I'm asking for the total amount, the total number of tons, okay, so how many tons of unprocessed gravel have arrived at the plant, so we're talking about the function that's giving us the rate that it's arriving during the hours of operation. So the hours of operation was from 0 to 8 on this workday. All right, so this is my function that measures the rate at which it's coming in. And if I want the total number of tons, well, this is measured in tons per hour. If I want to go backward to just tons, then that means I'm taking the integral. So I'm doing the integral from 0 to 8 of g of t dt. And so this is, again, calculator question. I should be able to just enter that in my calculator and get an answer. All right, so go ahead, pause the video, make sure that you can enter that in, and we'll see if we get the same answer. Okay, so my answer was 825.551 tons of unprocessed gravel. And as far as points, you get 1 point for having this correct integral and 1 point for having the correct answer. So that was a pretty easy 2 points. Let's move on to part C. Okay, part C says, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5 hours? Show the work that leads to your answer. All right, so we have to really understand what's going on here. First of all, the rate at which the unprocessed gravel is arriving is given right here. Okay, so we've looked at that several times, G of t. But there's another rate going on that we talked about before. And we said that it's being processed at a rate of 100 tons per hour. So they want to know, is the actual amount of unprocessed gravel increasing or decreasing? Well, we have to compare these two rates. This is the rate that it's arriving. This is the rate that it's being processed. And so at t equals 5 hours, how do those two rates compare? So first thing I have to evaluate is G of 5. Okay, so I'm just going to go ahead and enter that into my calculator and get an answer. So if you want to go ahead, pause the video, get that answer, and then come back to me. Okay, so the amount of, the rate at which the unprocessed gravel is arriving is 98.141 tons per hour. But then it's being processed at a constant rate of 100 tons per hour. And so at t equals 5, at 5 hours into the workday, the amount that's arriving is less than the amount that they are processing it at. Therefore, we would say the amount is decreasing. So I'm going to say that 98.141 is less than 100. Therefore, the amount of unprocessed gravel is decreasing at t equals 5. And I would just say that's because G of 5 is less than 100. Okay, and you could explain that in words by saying the rate at which it's arriving is less than the rate at which they're processing it. As far as points for this question, you get 1 point for basically this work here, for finding G of 5 and comparing it to the 100 tons per hour. And then the second point is for being able to interpret your answer and decide that because G of 5 is less than 100, then the amount of unprocessed gravel is decreasing. So 1 point for the comparison of G of 5 to 100 and 1 point for your conclusion. All right, let's move on to part D. Okay, this last question is probably the most involved, and it's actually a 3-point question where all the others were 2. It says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation during this workday? Justify your answer. So they want to know what is the maximum amount of unprocessed gravel. All right, well, there's 2 different rates that we have to keep in mind. This is the rate at which it's arriving. This is the rate at which it's being processed. And we just looked at this in the last question. If this rate is smaller than this rate, smaller than 100, then the amount of gravel is decreasing. If this rate is bigger, then the amount of gravel is increasing. So the idea is, if we can figure out when these are equal, then I would say I would have a critical value. I'd have a 0, right? I'd have a flat line, if you will. When I have G of t equal to 100, I would say that's when I have a critical value that I could either have, at that point, I could either have a maximum or a minimum. All right, so I'm going to actually take a step back and just kind of show you this using a formula. Now, I would say that on the exam, you don't actually have to write this formula, but you have to use this whole concept in order to answer the question. There's lots of different ways you could answer this and get full credit. So the idea here is that we want to write a formula to find the amount of unprocessed gravel. So I'm going to call that A of t. Okay, so A of t is the amount of unprocessed gravel. So, all right, first of all, they gave us this information that at t equals 0, we started with 500 tons of unprocessed gravel. So that's my starting value, 500. And then I'm going to add on to that the amount that is in the I don't know, what is it called? At the plant at any time. Okay, so how do I find the amount? Well, that means I have to go backwards from the rate. So I do the integral from 0 to t, okay, at any time t, of my rate that it's arriving. So I'm going to use g of x because I'm not, when I do this, I can't have the same variables. So I know that's confusing, but I'm going to use g of x. That's the rate it's arriving. I have to subtract away the rate that it's being processed. So g of x minus 100 dx. Okay, so that's the amount that's in the plant at any time. Now I want to find out when that's the maximum, so I'm going to do a prime of t. Okay, so if I took the derivative of this function, well, the derivative of 500 would be 0, so that would wipe that out. And then to take the derivative of this integral here, okay, well, what does that mean I would do? That means I would take this upper bound and plug it in for the variable x and evaluate it that way. So I would say this would be equal to g of t minus 100. Okay, now the question is, when is a prime of t equal to 0? Because you're trying to find your critical values. So g of t minus 100, and that's what we are talking about. Look, when 100 is equal to g of t, that's when the two rates are equal, when the rate that it is arriving is equal to the rate that it's being processed, that's when you have your critical values. And like I said, if you did that by writing this whole formula out and figuring that out, that's one way to do it. But if you just were able to recognize that when these rates are equal, that's going to be a critical value, that would have been fine as well. Okay, so to find the answer to this question, when g of t is equal to 100, I'm going to go ahead and graph my g of t function and graph the line y equals 100. I'm going to graph it over the window 0 to 8 for my x values, and then my y values, well, I have to get up to 100. And so you want to make sure that you're going maybe from 0 to 200 so that you can see when g of t is going to pass through that 100 mark. Okay, so let's go ahead, pause the video, and make yourself a graph to find the values of t when g of t equals 100. Okay, so you can see the graph that I made, and I would sketch something similar to this to show my work for how I got my answer. So you can see here that I graphed it. Of course, I would have to include all this information. So this was from 0 to 8, and over here it was from 0 to 200, so this was the line y equals 100 here. Okay, and then obviously this is my function g of t here. And you can see they intersected, and I have the intersection point labeled out. All right, so I found that they intersected at a time of 4.923. I went ahead and stored that into A just so that if I needed it later, I would have it. And of course, I am going to need it later. So I stored that into A. Like I said, I would make a sketch of this graph, or I would state how I found it by saying that I graphed the two functions and found where they intersected and held the window. So somehow you have to show your work for how you get that 4.923. Okay, so we have that time. Now what do we need to do with it? Well, if I'm finding the absolute maximum amount of gravel, I need to do a closed interval test with the values t equals 0, t equals 8, and my only critical value I found was that 4.923. So the next thing I'm going to do is that closed interval test with this function that I just wrote. Now, like I said, some of you might not have thought to write out that whole function. So how would you have done it? Well, you would have thought through the process. Okay, what am I doing? I'm going to start with 500. Then I'm going to find the amount that is being arriving. So that's this. And then I'm going to subtract away the amount that is declining. So that would be 100 times however many hours, because it's 100 tons per hour that's being processed. So however you want to figure that out, you would have to go through and find the amount that's at the plant at any time. T equals 0, t equals 4.923, and t equals 8. All right, so that's what we're going to do next, is make this closed interval test. Okay, so I made myself my t-chart here for the closed interval test, and I'm finding the amount of gravel that is at the plant at, like I said, time t equals 0 and 8. That's because those are the endpoints of the time interval. And then at my only critical value, 4.923. And I'm going to use this formula right here in order to figure that out. So I'm going to pause the video and get answers for each of these. Keep in mind that, of course, this is your g of x function, and then your 100 is just, you're just putting it in as 100. Okay, so pause the video. Get values for each of these different amounts of gravel, and then we'll see if we can compare and agree, and then we'll decide on the maximum amount. Okay, so I went ahead and entered in. The first one was really easy because as I was entering, it was 500 plus the integral from 0 to 0. So I knew that this whole second part was going to cancel itself out, and so therefore I just got the 500. Okay, but then the next one I used a for when my t. So I did 500 plus the integral from 0 to a of, and then I typed in this function, minus 100 dx, and I ended up with 635.376, and did the same for when t was 8. Okay, so clearly I see that I have a maximum at a time of 4.923, and it wants specifically, though, the maximum amount of gravel. So it doesn't want the time, it wants the maximum amount. So I would say max amount of unprocessed gravel is 635.376 tons. And that's it. So that would be my final answer for that and all that work. As far as points, okay, we've been talking about where you're going to get your points from. So I think that this is really important. It's not a waste of time. 1 point is for finding this. Your t equals 4.923. So recognizing that the fact that that happens when g of t is equal to 100, and then actually finding when g of t equals 100 is 1 point. And like I said, whether you thought to write that whole formula out or not, finding that t equals 4.923 was 1 point. The second point is your answer. Okay, so this actual is your second point, knowing that answer. And the third point is this justification. So this is a point. Now this point comes from a lot of stuff. This point comes from understanding this formula. And like I said, whether you conceptually understand and write out the entire formula, or whether you kind of broke it up in your head and did 500 in the calculator plus just the integral of this in the calculator minus the integral from 0 to t of 100 in your calculator. However you did it, that you were able to get these three values to compare to then say which one is the maximum. So that's where your 3 points come from. This was a big, definitely part D here, and lots to it. All right, so let's go ahead and move on to the next free response question. Okay, 2010 number 1, again with the calculator. It says there's no snow in Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates in the driveway at a rate modeled by f of t equals 7te to the cos t cubic feet per hour, where t is measured in hours since midnight. So we clearly, living in Buffalo, have an idea of what's happening here, right? So she goes to bed, there's no snow. From midnight to 9 a.m., snow is accumulating in her driveway at this rate of cubic feet per hour. All right, now, Janet starts removing snow at 6 a.m. So she wakes up in the morning and she's like, oh, I have to start removing this snow. So at t equals 6 hours, 6 a.m., she starts removing it. And the rate at which she removes the snow is modeled by g of t. And that's this, which is clearly a piecewise function. Okay, so part A says, how many cubic feet of snow have accumulated by 6 a.m. So we're just talking about the accumulation, okay? We're talking about how much snow, how many cubic feet total. So that's talking about taking the integral of the rate at which it's falling. So so I would say the integral from 0 to 6 a.m. of f of t dt. And I'm just going to go ahead and enter that into my calculator and get an answer. So pause your video, come back, and get an answer. Okay, so my answer was 142.275. All right, let's move on to part B. Okay, so part B says find the rate of change of the volume of snow on the driveway at 8 a.m. Okay, so this is very similar to the last one with the gravel. There's two things happening here. There's snow that is accumulating, and that's constant. That is this rate, okay, over the full 9 hours. But then, starting at 6 a.m., okay, she starts removing it, and that's followed by this. So at 8 a.m., what is the rate? Well, in order to figure that out, I would have to say, well, what's the rate it's accumulating at 8 a.m.? So f of 8 minus the rate which she's removing it, so g of 8. All right, and that's all I'm figuring out, f of 8 minus g of 8. So I'm putting in 8 in for the function for f, and then putting it in for my g function. So I'd say 7 times 8 e to the cosine of 8 minus, all right, g of 8, well, I have to specifically look at these time intervals over here, and clearly 8 falls in this one, so minus 108. And so I'm just going to type that into my calculator and get an answer. Come back to me when you have an answer and see if we agree. Okay, my answer was negative 59.583. You don't need a unit of measure because they didn't ask for it. This is actually just a 1-point question. So understanding the concept that the rate at which it's accumulating, take away the rate at which she's shoveling it, and you'll have the rate at which the rate of change of the volume of snow on the driveway at 8 a.m. All right, let's move on to part C. Okay, so part C here is asking, it says, let H of T represent the total amount of snow in cubic feet that Janet has removed from the driveway at time T hours after midnight. Express H as a piecewise defined function with domain 0 less than or equal to T less than or equal to 9. So we are finding the total amount of snow that she's removed from the driveway. So if I want the total amount that she has removed, I definitely want to be looking at the rate at which she's removing it, which is g of t. Okay? And so h of t is going to be another piecewise function. And basically, we're going to follow these same 3 time intervals from 0 to 6, from 6 to 7, and from 7 to 9. Okay, and so we need to find basically the amount of snow that she has removed over those different time intervals. All right, well, the first one's really easy because from 0 to 6, if she's removed it at a rate of 0 cubic feet per hour, then how much has she in total removed? Well, I would be able to safely say that she's removed none. Okay, she starts removing it at 6 a.m. and from 6 to 7 she's removing it at a rate of 125 cubic feet per hour. So if I want to find the total amount that she's removed, okay, I'm going to kind of do my work off to the side over here. So from 6 to 7 hours, well, what would that be? Well, I would do the integral from 6 to t of the rate, which is 125 dt. Okay, and so to evaluate that, I'm just going to go ahead and calculate the integral. So that would be 125 t from 6 to t. All right, so when I plug that in, I would get 125 t minus 125 times 6 is 750. Okay, so that right there is the amount that she has removed in terms of t from 6 to 7. So I'm going to go ahead and put that in here, 125t minus 750. All right, now from 7 to 9, she's removed it at a rate of 108. But this one's a little trickier because from 7 to 9, okay, so I'm going to kind of do this work over here. So from 7 to 9, she's already removed a certain amount. Add on to that the amount that she removes from over the next 2 hours. Well, how much has she removed? Well, take a look. If the time was 1 hour from 6 to 7 and she's removing it at 125 cubic feet per hour, then it looks to me like she's removed exactly 125 cubic feet. So we start off with the 125 that she's already removed, plus, again, the integral from, this time it would be from 7 to t of 108 dt. All right, so that would be 125 plus, we're going to do the same thing we did before, 108 t from 7 to t. All right, so it'd be 125 plus 108 t minus 108 times 7 is 756. And so I'm just going to go ahead and combine those, 125 minus 756. And I get negative 631 plus 108t. And that's what's going to go in my last one here. So 108t minus 631. All right, and so that gives me all of the different total amounts that have been removed from her driveway over the hours t equals 0 to t equals 9. So you might want to take a look at that again and just really process what we did here. If you look at the answer in your green book, it's written out a little bit differently, but it represents the exact same answer. This way makes more sense to me, so this is the way I explained it. All right, let's move on to part D. Okay, part D says how many cubic feet of snow are on the driveway by 9 a.m. All right, so this is, again, very similar to the problem that we just completed. We have two different rates that we have to keep in mind. How much has accumulated? Well, total amount accumulated, okay, that would be the integral of that function right there. So the integral from 0 to 9 of f of t dt. That'll tell how much has accumulated. However, Janet has been busy at work and she's been removing, okay, the snow. Now we just found an expression for the total amount that she has removed that was h of t. And so minus the amount that she's removed by 9 a.m. would be h of 9. Okay, so I'm going to calculate each of these pieces separately. The amount accumulated over the 9 hours is 367.335 cubic feet of snow. Okay, minus h of 9. So I'm going to go back and grab the formula for h of t at between the hours of 7 and 9. Okay, so I have that formula as 108 t, which my t is 9, minus 631. All right, so I'm going to go ahead and evaluate that. So 108 times 9 minus 631 in my calculator is 341. So I have 367.335 minus 341. Okay, so I'm going to go ahead and subtract those in my calculator, and I get 26.335 cubic feet of snow on the driveway at 9 a.m. And that is the final answer for that one. Okay, so both of these problems had similar features to them. Both of them were talking about the rate of something falling or arriving, and then the rate at which something is being taken away or subtracted from. And so you have to understand this idea. It's somewhere in these questions. In this one, it was part C and part D, where they're talking about using both functions, okay? It's arriving and then being taken away. And so this concept of putting those together or subtracting those to find how much is on the driveway in this case, or in the plant in the first one, at a given time. All right, so I know this was a long video, but if you are still confused or stuck, I would go back and rewatch. These real world rate of change kind of problems, they come up pretty frequently, whether it's from a word problem like this or from a graph. So the next video is going to be on some graphs. These ones obviously looked at more word problems. All right, I'll see you next time where we get to practice a few more of these in class. Have a great night.